All right, guys, in this video, we're going to take a look at volume of a sphere. Now, let's talk a little bit about spheres before we move forward to looking at the exact volume formula. So one thing to think about is that a sphere is made up by two hemispheres, okay? So if you think about the, when we talk about globes, there's the northern hemisphere and the southern hemisphere based off the equator, okay? So a sphere is just made up of two hemispheres, and a hemisphere is half a sphere. So notice here, I've got half a sphere on the bottom, half a sphere on the top. That's what we're going to be looking at. Now, our volume formula for a whole sphere is volume is equal to 4/3 pi r cubed. All right, so this is one that we're just going to kind of understand. If you think about that it's a volume, you're going to need to multiply three things together. In this case, the only dimension we don't have a height, we don't have a width, we only have a radius. So we end up doing radius cubed, and then you get pi times 4/3. So it's pretty straightforward. So let's go ahead and let's take a look at a problem or two. So let's look at this one here. Actually, let me make this so we can actually see both sides. All right. We are not going to use pi to the nearest tenth, though you could if you wanted to. We're just going to use pi. So let's set this thing up. It's just 4/3 times pi times 5 cubed. All right. So 5 cubed, that comes out to 125 times 4/3. So that comes out to something like 125 times 4/3 times pi. We end up with 523.6. All right, and then let's look at our volume for the next one. So I've got, 11, so my radius here would be 5.5. Because again, notice this is the diameter, so I'd have to find the radius. So I would plug this in, 4/3 times pi times 5.5 cubed. All right, so that's going to go almost exactly the same as before. 5.5 cubed. And remember, if you're trying to get cubed on your calculator, it's the little caret button above the division sign, or if you look under the functions in Desmos, that will also get you the cubed function. All right, times pi, and we end up with 696.9. All right. Let's work backwards here. So this time they give us the volume at 288 pi, and they want us to find the radius. So let's set this thing up. 288 pi is equal to 4/3 pi r cubed, right? Well, right off the bat, I can divide both sides by pi, so that makes things simpler. And then the 4/3, what I'm going to do is I'm going to multiply both sides by the reciprocal. Remember, reciprocal is a fancy word for a flipped fraction. So I'm going to flip the fraction upside down. The 4s will cancel out, the 3s will cancel out. So let's do 288 times 3 divided by 4, and we get 216 is equal to r cubed. Now, if you're familiar with your cube roots, so we're going to take the cube root of both sides, and once again, if you want to do that on, your calculator, you're going to hit the math button. It's on the left side of your calculator, 3 down from the top, and it'll be option number 4. If you want to do it in Desmos, once again, look in the functions category. It should be there. All right, so I take the cube root of both sides, and I get 6 is equal to r. So in this case, we had the volume. You work backwards to find the radius. Let's look at one problem here where we're doing some sort of composite figure, okay? Notice what I have going on. I've got a cylinder, and then I've got a hemisphere. So I've got half a sphere on top of the cylinder, and I want to find the volume for this composite volume. So tell you what, we can zoom in a little bit here. So let's take a look here. So a couple things to notice. I have the radius and the height of my cylinder. Both of them are r, and I know that r is equal to 5. So if I'm thinking about volume of a cylinder, it's pi r squared h. Okay, and this is my cylinder is equal to. And then I'm going to do h for hemisphere. Instead of 4/3, well, it's 4/3 pi r cubed, right? But in this case, I'm only doing half of the sphere, so I'm actually going to do 1/2 times 4/3 pi r cubed. So I could actually rewrite that as 2/3 pi r cubed. Okay. Now, let's think about the cylinder formula. Remember that our height in this case is actually equal to my radius. So what I end up with is pi r cubed plus 2/3 pi r cubed. Okay? Notice this pi r cubed is because I'm doing r squared times h, but my h is actually equal to my radius. So this would be the entire volume, okay? This is going to be my whole volume, and we're going to go ahead and solve that. So we've got pi r cubed ends up being the cylinder volume. So pi 5 cubed plus 2/3, because we're only doing half of the sphere, times pi times 5 cubed. And we end up with 654.5. All right, guys, because there's only one variable that's just a radius, dealing with spheres is actually quite simple. There's just not a lot going on. It's not that difficult, okay? You can work forward, you can work backwards. There's going to be some composite ones where you can either add, or maybe it's like a hemisphere has been dug out of a certain shape, in which case we would subtract. But on the whole, spheres are, I think, one of the simpler things we cover. So hopefully this is helpful, but this wraps up our lesson on volume of spheres.